Hello and welcome back. We have understood k-means clustering and the k selection approaches, the, the elbow curve and silhouette score, right? Silhouette analysis, right? So, and we looked into a code example also. Now it is a good time to look into what is silhouette score and how it exactly calculates and what is it exactly calculating, and how can it distinguish the whether the clusters are overlapping or close to each other or far from each other. So I have taken three different scenarios and try to come up with an explanation. Let us see how it goes. Clusters far from each other. If two clusters are far from each other, how the silhouette score is going to be? If you look at this, individual samples scores are going to be close to 1. When two clusters are far from each other, the individual scores of the data points are going to be close to 1. Okay, that is first point. The second point is the farthest data points silhouette score is going to be higher than the closest data point. If the two clusters are like this, the farthest data points silhouette score is going to be higher than the closest data point silhouette score. Let us see how to calculate that and see. So the silhouette score formula is bi minus ai divided by maximum of ai and bi. What is bi and what is ai? ai is the average of the distances within cluster, within distances between the data point and the data points within the cluster. If you see this, there is a green cluster and there is a maroon cluster, right? So I have chosen this S1, a data point which is close to the maroon cluster. And to calculate AI, what I need to do is I need to calculate distances between this data point and all the other data points. If you see this here, this is the data point, 300 and 380 is the data point, and the cluster it belongs to is 1, green is 1 and maroon is 0. So the distance between that data point and that data point is 0, right? This data point and other data points are these green areas, this green area. I calculated that. Average of all these data, all these distances is this is Euclidean distance actually. The data point and the other data points distance are Euclidean distances. And then the average is 21.81, that is AI. And what is BI? The distance between, the average distance between this data point, this whatever current data point for which we are calculating silhouette score, and the other data points in the closest cluster. We need to remember that closest cluster. How do you know which is closest cluster? A formula is like this: minimum of the average distances of the first cluster, the average distance of second cluster, average distance of third cluster. We have n number of clusters are there, then you need to calculate the distance between this data point and all other clusters and look at the minimum of first cluster average, second cluster average, third cluster average, like that. Whichever is minimum, that's the score you get, BI. Here only two clusters, so you can take the red area. All these distances are from this data point. This data point to this data point is 89. This data point to this data point is 108. And what is that? Euclidean distance, right? This data point to this data point is 89. This data point to this data 94, like that. So we calculate the average, that is BI. When you substitute this one into this formula, right? BI minus AI divided by maximum of BI minus BI and AI. What are we trying to do? We are calculating the distance between the current data points average distance to within cluster and other the closest cluster. It is distance, right? BI is the average of the closest cluster's distance. AI is the average of within cluster's distance. We are taking the distance between those two and normalizing it with the maximum of AI and BI. When you normalize it, right, score it comes between -1 and +1. If you don't normalize, right, the number can be any number, right, between -infinity to +infinity. Okay, so when you normalize, the score comes between -1 and +1. So that's how the silhouette score is calculated. If the clusters are far like this, right, when I calculate silhouette score, it is 0.776, which is close to 1. Okay, the same thing in same cluster setup. I chose one closed data point and closed data point to the closest cluster. I've got 0.776. If I chose a farthest data point and calculate the farthest data point to the closest cluster. I calculate the silhouette score, I got a little more. See this? 0.77 and 0.82. So this data point is close to the closest cluster. This data point is far from the closest cluster. That's what the point I was actually trying to mention before. If the data point is close to the closest cluster, you will get a score close to 0. If clusters are far from each other, you get a number close to 1. If in that, if the data point is close to closest cluster, the number is going to be close to 0, right? And again, in the same cluster, if you take a data point which is far from the cluster, you get a higher score, which is close to 1. So that is one scenario. The second scenario, closest clusters to each other. Individual sample scores are going to be close to 1. In this first setup, far clusters, individual sample scores are going to be close to 1. See this here, here. And the second setup, the clusters are close to each other, then the individual sample scores are going to be close to 0. Even here also, farthest sample score is going to be greater than closest sample score. See this here. I have taken closest sample to the closest cluster. When I say closest sample to the closest cluster, okay, and the clusters are close to each other. See this, they are close to each other. If you compare this, these are far from each other, these are close to each other. Now I calculated silhouette score, I got 0.175, which is close to 0, right? Now I'll take a data point which is far from the closest cluster. See this, the score is high, 0.593. Okay, the third scenario is overlapping clusters. When clusters are overlapping, I said the sample score, each individual silhouette score, each individual sample's silhouette score is going to be close to 0 or negative, -1. Okay, here also farthest sample's score is going to be greater than closest sample. See this, overlapping clusters, both are overlapping to each other. When I calculated the data point which is closest to the cluster, I've got -0 negative score I got. Okay, and then farthest point I got a score which is close to 1. So when clusters are overlapping, all the silhouette scores are going to be close to -1 or 0. When you take average also, it's going to be -1 and 0. That means clusters are overlapping. When they are far from each other, the scores are going to be close to 1. Whether it is closest data point or farthest data point, the scores are going to be close to 1, right? In that case, what happens? Average is also going to be close to 1. That means clusters are far from each other. They are close, right? The scores are going to be around 0 and you will get a score around 0, right? So that's the silhouette score and how it works. I think it makes sense, right? If you look at the this video one more time and slides one more time, you will understand better. So there is another concept called as silhouette plot, the silhouette analysis we call it as. So if you look at this, right, they look like knives, right? So for each data point there is a silhouette score, right? If you try to take the cluster 0 and give one color to all those data points which are falling in the first cluster, and take silhouette coefficient, the score on the x-axis, silhouette score on the x-axis if you take, and then try to plot it like this, right? We got these kinds of curves. This is one cluster, this is another cluster, this is another cluster, and this is another cluster. The height of the cluster actually shows you number of data points present in the cluster, and this red line is the average silhouette score. The average silhouette score, if the knives are penetrating through or coming out of that average score, right, that means clustering is happening properly. Okay, the width actually says that sorted silhouette scores of the instances in the cluster. So width indicates that the silhouette scores, they are high, right? Most of the silhouette scores are high, that's when it actually crosses the score. That means this cluster is actually far from the other clusters. This cluster is kind of close to the other clusters, but overall all these clusters are actually forming well. The height actually says the number of instances. At a high level you can understand how many number of instances. It is not going to give you clear number, but it shows that there are more data points in this cluster when compared to this cluster. So this is called a silhouette analysis. you can do this plot. It is, it is a the matplotlib seaborn stuff. It is, you can do that. So in silhouette analysis, n number of columns you may have, but after calculating silhouette scores, right, you can do this plot and understand how exactly data got splitted. If the heights are similar, then the data is splitted into equal number of, equal numbered sized clusters or groups. So that's about silhouette score. We'll meet with DBScan in coming session. Thank you.